Good day to you all. Right, we are looking or recapping on velocity time graphs, and we are going to look at 3 examples. Then I will give you an exercise. So, as a recap on velocity time graphs, our velocity will be on the y-axis, then time on the x-axis. There are certain aspects that you should know when calculating the acceleration. That acceleration is velocity over time. And what is the significance of velocity over time is the gradient. So if you are asked to find the acceleration on a velocity time graph, you find the gradient of the graph. And also the displacement, the total distance covered by the particle under the velocity time graph. You must know that you should find it using calculation of the area under the graph. So make sure you know the formulas to calculate the area of a square, the area of a rectangle, the area of a triangle, and the area of a trapezium. You should know all the aspects of that. So the displacement is the area under the velocity time graph. So I hope you have done these examples, but I want to demonstrate questions on the exercise below. This question on exercise 1.2. On exercise 1.2. So on exercise 1.2, you are going to take number 1, number 3, number 4, and number 6 as your exercise. Number 1, number 3, number 4, and number 6 as your exercise. So I'm going to help you to demonstrate on how you can answer number 2. So on number 2, as you can read number 2, they are saying a basketball is thrown vertically upwards from the ground with the initial velocity of 20 meters per second. The acceleration due to gravity is 10 meters per second downwards. Sketch the velocity time graph to show the motion of the basketball from the time it is thrown until it reaches the ground again. So we are going to use the Sylvert equations to come up with a velocity time graph, where we are saying we have our x-axis, which is going to be t, and for the y-axis we have the value for the velocity. So probably since velocity is a vector, you might have the negative velocity. So we want to draw the velocity time graph. So we want to identify the key terms or key points we need to calculate. So initially implies that t is equals to 0. As you can see here, initial velocity is 20 meters per second. So initial, it implies that t is equals to 0. So at t equals to 0, we have the velocity 20. So that is the first thing. So since the acceleration is constant, so if we have a constant acceleration, it means the graph for the velocity time graph is a line, because the gradient of a line is always constant. So throughout our motion, the acceleration is what is constant. So if you throw a ball, that would be a projectile. So if you throw a ball we are going to observe a two-way. Our velocity is going to increase and also decrease. So let's say this is a ball. You 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 throw the ball vertically upwards, and the acceleration of gravity is always acting downwards. So the moment where the ball is moving upwards, acceleration is acting downwards. So the velocity will be decreasing since the acceleration is acting downwards. So when moving upwards, when the ball is moving upwards, it reaches the maximum height. So when it reaches the maximum height, it will go down again. So when the ball is moving vertically upwards, it is decreasing the velocity, because at maximum our velocity is what is 0. So at maximum, so from here to here, the velocity will be decreasing. So it's a straight line. The velocity will be decreasing. So until we get a velocity of 0. So we are going to find the time to reach the maximum. Then from the maximum and going back to the ground, the velocity will be increasing since in the same direction with the acceleration, but it will be increasing in the opposite direction. So it will continue here. So with the graph, it will continue here to move downwards. To continue here to move downwards. To continue here to move downwards. And you must know that the time taken to reach the maximum height is also the time taken from the ball from the maximum height to reach the ground. So if you find this time, we are going to multiply it by 2. Then we are also going to find the time taken, the whole time taken. So let's calculate so since the times are equal, so this will be the negative velocity. So we have a negative velocity here, right? So when you want to calculate the time, we see which values are we given. We are given the initial speed. U is equals to 20, right? And we are given acceleration is equals to 10, which always acts downwards. And we want to find t. We don't know the value of t, but we know at maximum height v is equals to 0. So if you have come up with this equation, v is equals to u plus at, we are going to use this equation to find the value of t. V is equals to u plus at. So where there's u, there's a v, you put 0. So 0 is equal to our initial, it's 20. Then when the ball is moving upwards, your acceleration will be negative. So it's negative 10 times t. Then if you take this to this side, you are going to see that we have 10. We are going to have 10 t. 10 t is equals to 20. Then we divide each term by 10. Then our time will be equals to what? Is equals to 2. This is the time to reach the maximum height. So this is the time to reach the maximum height. So we have 2 here. So we have 2 here. And we said the time to reach the maximum height is the same as the time taken by the ball from the maximum height to reach the ground. So if we multiply by 2, we are going to have 4. So this is the required velocity time graph for the baseball thrown vertically upwards from the ground with an initial speed of 20 and acceleration due to gravity of 10 acting downwards. So if the ball is moving upwards, make sure your acceleration is negative. It will be decelerating. That's why it decreases to 0. So if velocity is 20 and at maximum equals to 0, it implies that velocity is decreasing, body is decelerating. So from the maximum height downwards, the velocity will be increasing, but in the opposite direction, since velocity is a what? Is a vector. Direction is very important when you are dealing with vectors. So moving on to number 5, right? On number 5 here, we are given this diagram, right? We have a velocity time graph that shows for the first 35 seconds of the motion, a car as it moves on to a highway. In the first 10 seconds, as you can see from the diagram, it accelerates. That's why we have the line here from rest up to 60 meters per second on a slip road. It then travels for 10 seconds on the slip road at a constant velocity. So it's from here, it travels further 10 seconds. So 10 plus 10, you have 20 on a slip road before joining the highway. So the highway starts from here and accelerate for another 15 seconds, reaching the velocity of what? Of 40. So part A, find the acceleration when t is equals to 5 and when t is equals to 30. So like what we have highlighted earlier, acceleration is the of a velocity time graph is just the gradient of the line. So 5 at time 5 seconds, we are going to the acceleration at 5 is the same as the acceleration of this line. So on part A, on part A, the acceleration at time t is equals to 5. It will be the same acceleration is the same as the gradient of this line. So the gradient of the first line here, say it's change in y, or change in y, that is 16 minus 0. So it will be 16 minus 0, final velocity minus initial, over change in time, change in y, which is 10 minus 0, which is 10 minus 0. So which is 16 which is 16 over 10, and 16 over 10 we are going to get 1.6. We're going to get 1.6 meters per second squared. Don't forget to put your correct units. So during the first 5 seconds, the acceleration is the gradient of this one. Then during the time t is equals to 30, as you can see here, t equals to 30, as you can see here, we are going to use the second line, third line here, the acceleration of this one. So this one is at t is equals to 5. This one is at t equals to 5. Then at t is equals to 30. At t is equals to 30 here, we are going to look at the gradient of this line. So again, our acceleration is changing velocity, which is 40 minus 16, which is 40 minus 16 divided by time taken, that is 35 minus 20. 35 minus 20. So we are going to get to get 1.6, that will be 40 minus 16 divided by 15. We are going to get 1.6, 1.6, again 1.6 meters per second squared, again 1.6 meters per second squared is the acceleration. Then on part C, right, so moving on to part B, they are saying find the distance traveled by the car on the slip road. So again, if you read the question, the slip road is for 10 seconds, then for a constant speed of 40 for another 15 seconds. So for the slip road, we are going to have the area of a shape from 0 to 20 seconds. So on part B, let's say we have the area of a triangle here. We have the area of a triangle, and the area of a triangle is half base, and our base is what? From 0 to 10, it's 10. Then times our height. So the height from 0 to 16. That's the area of the first triangle. Plus, then we combine. This will be the area of the rectangle. Area of the rectangle, length times width. So from 10 to 20, the length is 10, then times the width from here to here is 16. So here we are going to have half of 10, 5 times 16, we are going to have 8. So it's 80 meters, right, plus 10 times 16, we are going to get 160 meters. So if you add the two, the total distance on the slip road is going to be 240 meters. 240 meters. That is for part B. Then for part C, the total distance covered by the car during the first 35 seconds. So the total distance, the area of this under the area under the graph here, we are just going to take this 240, because from here from 0 to 20 we have 240. One can use the area of a trapezium, because this shape is also a trapezium. We say half of base times the A times B plus B, then times height, which is 60. One can also use the area of a trapezium. Still you get the same answer. So the total distance traveled, we are going to take this 240 here, the one that we have here, 240. Then with that 240, we are going to add with the area of the trapezium, this trapezium, the last trapezium from 20 to 35. So here will be our A, B, then your height here is H. So we are going to say plus half of A plus B, the area of a trapezium. I think you know the area of the trapezium. So this A is 16. We have 16 here. A plus B is 40. Then times the height from 20 to 15 to 35, which is 15. So this one is 16. Right. So if you simplify 240 plus this one, can you please take your calculator? And if you simplify, you are supposed to get 660 meters. 660 meters. So this is the total distance traveled. This is the total distance traveled during the first 35 seconds. During the first 35